Okay, this will be section 3.1. So we're going into different numeration systems. The one that we use is Hindu Arabic. That's the one we're familiar with. But we'll look at other systems, specifically different bases like base 2, base 5, etc. Hindu Arabic, that's our favorite one, the base 10. That's what we got, properties and symbols that represent our numbers. So just to play with this, we know that this equals 234. We know stuff like this, 10 to the 4th is 10 times itself 4 times is 10,000. So we're using properties like exponents. Here we're using place value, which is huge in this class. So properties, symbols. Here's some other ones from throughout history. You may be familiar with some of them. I would bet you've seen Roman numbers. Here's our Hindu Arabic. There's ours. Look at all these different symbols. But what's kind of neat about this is think of the Romans and how advanced they were, and the Greeks. But notice they didn't have a symbol for 0. The Mayans did. The Mayans are also very advanced. So their number system was much more advanced than the Greeks and the Romans because they had place value as well, which is a more advanced concept. There's us, base 10. You know this. The units are ones place, tens place, etc. So we read this as 5,678 because of the place value. And there's really a strong emphasis on this in the Common Core and elementary school now. That's the worst D I've ever written. Okay, expanded form. Because this is in the thousands place, we have 6 of them. We don't write it 6 times 1,000. Instead, because 1,000 is 10 to the 3rd, we write it as 6 times 10 to the 3rd. The reason we learned this in base 10 is so we can do different bases like base 5, which we will see shortly. Notice here, 9 times 1, really, that's 10 to the 0 power, because if you think of your rules of exponents, a to the 0 is 1. Base 10 blocks, I wish we were in class so we could play with these. I'm trying to find some virtual ones online. May just have you cut some out of cardboard or something and play with them. But they're really good to learn how to regroup and how to combine different numbers, because we're going to get rid of the borrow a 10 or carry a 1 kind of language. So here's a base 5 system. So with base 5, notice here, you can have 1, 2, 3, 4 in the ones place or the units place. But then suddenly, once you get a collection of 5, because it's base 5, that moves over to the second place value. So this number, 1, 0, is, if I do expanded form, this is 1 times 5 to the first plus 0 times 5 to the 0 is 5 plus 0 is 5. Notice again, we're in the units place. As soon as we get a collection of 5 in the units place, that 5 gets moved to the next place value. So this is 2, 0 base 5, which happens to be equal to 10 in base 10. Okay, I'm going to convert this base 5 number. PowerPoint didn't do this well. Generally, you will see this written this way: 1, 1, 2, 4, 4, with the 5 down there telling me it's the base. Now, to do this, I'm going to use expanded form. And I need it in base 5. So I'm going to start doing this. 5 to the 0 is 1. 5 to the first is 5. That's the 5's place. 5 squared. Actually, I don't even need these. I'm doing the 5's places. Sorry. Because I have 1, 2, 3, 4, 5. Okay. So what I can do now is I'll look at my number. I'll spread it out here a bit. Okay, this is the 5 to the 0 slot. This is 5 to the first. 5 squared. So notice it's looking just like base 10, except these are now powers of 5. So in expanded form, I have 1 times 5 to the 4th plus 1 times 5 cubed, 2 times 5 squared, 4 times 5, because 5 to the first is 5, plus 4 times 1, because 5 to the 0 is 1. Now we're going to need a calculator here. This is 1 times 625, that's 5 to the 4th. 1 times 125, 2 times 25. I don't know why that changed to that. Plus 4 times 5. And I'll leave the 4 times 1 there. This would be 625 plus 125 plus 50 plus 20 plus 4. Gives me the value 824. That's my base 10 number for this base 5 numeral. And I can do that with any base. So let me just see what's coming up. Base 2. It's called binary because you only get 1s and 0s. There. There's a different base. I'm going to convert to base 10. Again, PowerPoint failed me. Excuse me, there's my base 2 number. Let me just do this way. 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth. So again, I'm going to use expanded form. One times 2 to the fourth, 0 times 2 cubed, and so on. Notice just ones and zeros. One times 16, that's 0. 1 times 4, 1 times 2, plus 1 times 1. So 16 plus 4 plus 2 plus 1 is 23. That's the base 10 number. Okay, now we're going to go the other way. This is not as easy. The book has a technique that I don't employ because, I don't know, it's not straightforward to me. So here's what I'm going to do. I'm going to do it in base 2, and then I'll do it in base 5. So at base 2, I need this. I need 2 to the 0 is 1. I need all my place values in base 2. Notice I'm just doubling here for each one. And I'm going up until I get one that does not divide into 478. 2 to the 8th is 256. Looks like I gotta go one more. 2 to the 9th is 512. Okay, so I don't need 2 to the 9th. But my 2 to the 8th, my 256, actually goes into the 478. So I'm going to break this down. This is 1 times 2 to the 8th. Now I'm going to subtract 2, 2, 2, and I check. Do I have a 2 to the 7th? Yes, I can do that. I have one of those. In base 2, the most you can have is 1. Okay, 494. And I have a 2 to the 6th that will divide into that because that's 64. Difference is 30. Now, I don't have a 2 to the 5th because 30 is too much. But I write the 0 in there because it's very important because it's holding that place. But I will have a 2 to the 4th. I will have a 2 to the 8th. Or I'm sorry, 2 to the 3rd, which is 8. I need a little more over here because I have a 6. And wow, I hope you saw this before I did. I kind of need 2 to the 2nd equals 4 in there. I was on autopilot. That's 1 times 2 to the 2nd, so at least I caught myself. Now I have 1 times 2 to the 1st, which is 2, and then I'm down to 0. But it's very important that you say I have 0 times 2 to the 0 in there because that will keep the place value. So my base 2 numeral for the base 10 number 478. Now I just go down the line. 1, 1, 1, 0, 1, 1, 1, 1, 0, base 2. So 2 to the 0, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 2 to the 8th. That's where we started. Now I'm going to do it to base 5. So I want to do 478 and convert it to base 5. I need my base 5 numbers. So there's 1, 5. Let's remember 5 squared is 25. 5 to the third is 125. 5 to the fourth is 625. We can stop because 625 does not divide into 478. But 125 will, and it will do it 3 times. So I have 3 times 5 to the third. I have 5 squareds that will go into 103, 4 of them. Now I have 3 left over. I have 0 times 5 to the first, but I have a 3, which is 3 times 5 to the 0. So now I'm done. So in base 5, this number is 3403, base 5. You can practice this technique. You could try converting it to base 3. Okay, these are some of my favorite problems because it teaches us to regroup. So we do regroup and we do exchange. In this case, I'm going to do regrouping. I'm going to start with base 3. So base 3, when I have 3 in the units, it becomes one of these in the 3 to the first slot. See, this is 3 to the 0, 3 to the first, 3 squared, 3 cubed. Well, I can do another one, and that goes here. So what's left over in my 3 to the 0 slot is 2. I do the same thing here. When I get 3 of these all regroup to give me 1 in the 3 squareds. Looks like I have another one. And I have 1 remaining, so I'll write a 1 down there. Do it again. Here's a group of 3, goes over as cubes. I'm not so good at drawing. I have another one, so I get another one over here. So I have 0 left over. Now, I have 3 of these that can regroup. I can't draw in 5 dimensions, but I know it's a 1 with 1 remaining there. So my base 3 numeral for this mess is 1, 1, 0, 1, 2, base 3. I want you to think about that before I set this up for base 6. Okay, think about what we're going to do with base 6. We're going to regroup, but now we're going to regroup and exchange groups of 6. So with base 6, I need 6 of them. There we go. They regroup as 1 here. So this is the 6 to the 0, 6 to the 1, 6 squared, 6 cubed. So I have 2 left over. 2, 3, 4, 5, 6. Okay. 0 left over. I get 1 of these. 1, 2, 3, 4, 5. There's no regrouping. There's 5, and there's 2 of those. So my numeral is 2502, base 6. So you can practice this with any base that you want. And that's it. On Zoom. Let me stop the recording.